Alright, so in section 12.6 we'll talk about something called the unit circle, which is a pretty important idea in trigonometry. What that is, how to find something called the period of a function. The periodic function means something that kind of repeats, so the graphs of sine and cosine would be examples of periodic functions. And then we'll use a unit circle to find what are called exact values of trig functions. So these are types of problems where you wouldn't necessarily have a calculator, you need to find the exact value. Calculators usually don't do that. First of all, what is a unit circle? It's a circle that has a radius of 1. Unit means the number 1. Okay, so a unit circle has a radius of 1, and its center point is right here at the origin, which is the point 0, 0. Okay, if you were to draw a triangle, and you can see this picture right here, if you were to draw a triangle, which I'm outlining in green right there, that triangle has a hypotenuse of 1, because that's the hypotenuse of that triangle is also the radius of that circle. And we said that because it's a unit circle, by definition, what does it mean to be a unit circle? It means it's a circle with a radius of 1. Okay, this point right here, which we don't know what it's called, so let's just call that point x comma y. That means this distance right here, which I'll put in red, this distance must go from 0, 0 to x, 0. And that means it has a distance of x. And by the same reasoning, that distance right there, the vertical one, has a distance of y. If you look at that angle right there, let's suppose we wanted to find the cosine of that angle, the cosine of theta. Cosine from SOHCAHTOA is adjacent over hypotenuse. The x is adjacent to it, and the hypotenuse is just 1. So cosine is x over 1. Well, that's another way of saying that the cosine is the same as the x coordinate on this graph. So that's useful to know. That means anytime if they tell you this point is on the unit circle, like let's suppose they just give me a random point, and the point is 0.4 comma 0.7, and they say find the cosine and the sine of that angle. Well, there's the cosine right there, because we know that cosine based on this is the x, and by the same reasoning we can find the sine. The sine of this angle theta, sine is opposite, which is y, over hypotenuse, which is 1. So the sine is just equal to the y coordinate. Sine is equal to y. So that means if they just gave me that point, I would know right away that the sine is 0.7, because sine is equal to y. Okay, that's the main idea that comes out of the unit circle. Okay, the unit circle is a circle that has a radius of 1, and the x coordinate anywhere on that unit circle represents the cosine, and the y coordinate anywhere on that circle represents the sine. That's basically what we mean by unit circle. That's the main idea. Alright, the other thing that they point out to us is that this occurs, or this same reasoning applies to other quadrants, and we'll see this more in just a sec, so I'll pause on this. They are called, sine and cosine are called circular functions because you can define them using a circle. Notice that a circle repeats, right? You go around, you're back where you started, you go around again and again. When we graph sine and cosine, we'll see that that's how they look. Okay, so here's a picture of something on the unit circle. It says find the cosine and the sine. There's really not a lot to do here. You just have to recognize cosine is the x coordinate, sine is the y coordinate, and that's it. You're done right there. Okay, cosine is 1/2, sine is radical 3 over 2. And they didn't ask us to, but it would also be nice to find out what that angle is right there. Okay, and I think we may have mentioned this before. If not, there are 3 main angles that you should, if there's anything you should memorize, and math is not primarily about memorization, but if there is anything that you should memorize, then you should memorize the ones that I'm about to show you. And I'm just taking a look to see if this might have been introduced in an earlier section. I think it was in, I want to say it was 12.3. Let me just double check here. Yep, it was 12.3. We talked about memorizing the following table right here. So this is a table of sine and cosine angles, and if you know these 3, you know pretty much everything you need to know. 30, 45, and 60. And the trick is that the sines count up and the cosines count down. And so everything is something over 2. Every value here is over a fraction over 2. The sines count up. Radical 1 over 2, radical 2 over 2, radical 3 over 2. So 1, 2, 3. Cosines go 3, radical 2, radical 1. Remember, radical 1 is just 1, so we don't really need to write the radical there. So now look at this. What angle has a cosine of 1/2 and a sine of radical 3 over 2? Well, cosine of 1/2 is right here. Sine is radical 3 over 2. That's a 60-degree angle. So they didn't ask us to find that, but we could find it by noticing that that's 60. The other thing I want to mention, because people sometimes get confused or they forget, how do you tell the difference? It's kind of like alphabetical order. Cosine comes before sine. Cosine is the x, and in the alphabet x comes before y. So cosine is x, cosine comes before sine, x comes before y. That's a nice way to remember. Alright, what is the cosine and sine of this point? That's the cosine and that's the sine. Okay, and that's in the, looks like that's in quadrant number, where x is positive, y is negative. That would be in quadrant number 4. So if this is our unit circle, maybe the point would be roughly right there. Let's say 3/5 comma negative 4/5. And here's the other thing. We may have talked, I think we talked about this acronym before. All students take calculus. What does that mean? It means in quadrant 1, everything is positive. In the students quadrant, only sine is positive. In the all students take, in the take quadrant, only tan is positive. And in this quadrant, only cosine is positive. So notice this is the cosine, that's the x, and it's positive there. This is the sine, that's the y, and it's negative there. It should be negative because in the fourth quadrant, you are below the x-axis. Here's the x-axis right here. If you go below that, your y values are going to be negative, and that makes sense. Okay, and there's sine being negative. That's what we'd expect in that quadrant. Okay, this is the answer to the question we talked about with the law of sines. Why do you sometimes get multiple triangles? And the answer number 2, it's a little bit different because you don't, law of cosines, you get a unique triangle. But if you use the law of sines in that second case, you might have to do this as well. And here's the main reason. The reason that you sometimes get 2 triangles is because of that right there. And that's taken from a good site that talks about mass stack exchange. So why do you sometimes get 2 triangles? Here's why. Let's draw this triangle right here, ABC. And I just want to show you why this might sometimes happen. So A is 33 degrees. Side A is 30. We don't know B. We do know side C is 32. That's all we know. Okay, the law of sine says we could take the sine of A, so sine of 33, over its side, and that's equal to the sine of angle C, which we don't know, over its side. If we cross multiply these, we would get this right here. And then we would divide by 30. And then to solve for C, we need to take the inverse sine right here. So we'll take the inverse sine of this side. We'll take the inverse sine of this number. Before we do that, I want to show you what that number equals. So 32 sine 33 divided by 30. 32 sine 33 divided by 30. So let's just calculate that real quick. So 32 sine 33, and we will divide that by 30. So that is equal to 0.58, and then let's actually take the inverse sine of that, and we'll get 35 degrees. Okay, 35 degrees. So so first of all, let's just write that down. So angle C is 35 degrees. And if we were to calculate this by adding those and subtracting from 180, I believe we would get 112 degrees. Okay, so remember, this number was 0.58, and the question is, why do we get more than one triangle? Here's why. Let's draw that unit circle that we just had. Here's the unit circle. This point, remember that the unit circle has a radius of 1, so that means all of these 4 red dots that I just drew, they're all going to have zeros or something with 1. So that coordinate is x is 0 right there, and y is 1. Down here, x is 0, y is negative 1. Here, x is 1, y is 0. Here, x is negative 1, y is 0. So sine, remember that sine is the y coordinate. So this right here, that's the sine, and that's also the y coordinate. Where does the y coordinate equal 0.58? Well, notice this is 1, and these y coordinates are 0. So 0.58 is a little bit more than half. So right here and right here, that y coordinate right there is 0.58. But notice, if we go over to the second quadrant, that has the same exact y value right there. That's also a y. It's on the same vertical height as that other 0.58. Y represents the vertical height. So we're at the same vertical height right there. Okay, this is why, and remember we calculated this angle. This angle was 35 degrees. But notice this right here, this is going to have a reference angle of 35 degrees. These 2 angles have the same sine, and I'll prove it to you in just a sec using a calculator. So what is this angle, this orange one right here? That orange one is going to be 180 minus 35. which is 145 degrees. Okay, 145. So that's what this says right here, and let me just move it so you can see it. This says 90 plus x and 90 minus x have the same sign. So what does that even mean? Well, that means these two things right here, those are both equal to some, and we don't really care about what x is, but basically if you were to take x equals 55, that's the solution to this. If you take 55 and you add it to 90, you get this. If you take 55 and you subtract it from 90, you get this. Basically means that there are two places where y has the same value. One is in the first quadrant, one is in the second quadrant. That's why you sometimes get two triangles, because there are two different angles that have this sign right here. So when you hit inverse sine on the calculator, you only get one of them, but I'll prove to you that the other one also equals 0.58. So we said 35.5. So let's take the sine of 35.5, and we'll round it to 0.52. Okay, that's 0.58. Now let's subtract that from 180. Okay, so 180 minus that is, we said 145, but it's actually like 144.48. Notice these are going to be the exact same. They're the exact same number. Why is that? Because according to the unit circle, there are two places where the sine or the y-coordinate are the same. One is in the first and one is in the second quadrant. So we may not quite have understood that before, but hopefully it makes a little bit more sense now that you know the unit circle. Okay, so that's the first thing. When we talk about the unit circle, we want to talk about what does it mean to talk about a periodic function. So periodic function is just something that repeats. And if you look at that graph right there, it's usually easiest to find out how long the period is by going from peak to peak. So that's the peak of the graph, and that's the other peak of the graph. This distance is one cycle or one period. That's what we mean by period. One complete pattern where you show every part of the graph. So you show a peak down to the low point, back up to the high point, and now you're restarting the graph. That's another cycle right there that I just drew. What's that distance? Well, the distance of the first peak starts at 0. The second peak starts at 360. That distance from 0 to 360 is just 360. So that is the period. The period or the cycle is repeating every 360. Okay, period right here, like I said, it's easiest to go from peak to peak. So in this case, they're giving us from radians. So let's just go from, show you some other examples. So that's pi to 2 pi. What's the distance from pi to 2 pi? It just equals pi. So the period there is pi, or in degrees it would be 180 degrees. And that's all you have to do, is find out what's the distance from peak. You could also go from the low points, but it'll be a little bit confusing to people because you can see there's kind of two low points there. So it's easiest to pick a unique point. Same thing here, you don't want to pick the middle point because this is not a full period. A full period goes from peak to peak and it covers all this stuff in the middle. So that's my recommendation, is pick a unique point and then see how long to get to the next point that's the same. Alright, this one says graph a function, or graph a function with period of 4. I'm just going to show you the picture. Why does this have a period of 4? Yeah, and you can graph any function that repeats every 4. Here's why, because if you go from peak to peak, this starts at 1, it goes to 5. What's that distance? That distance is 4. So any function that repeats, we could have done something else. So we could do some kind of weird pattern here. We could do, I mean, not that you would ever see this, but let's do some weird spiral here, and then some weird spiral. This is supposed to be the same thing. If that were 1 and that were 5, in some sense that would be periodic. I don't know if maybe some of the technical details are not quite right, but the idea is that as long as something repeats every 4, it would be considered periodic. Okay, so it didn't have to be written like that wave graph you saw. Some of these are like triangles or other shapes right here. Alright, here's a word problem, because obviously periodic functions are used a lot in real life. Any cyclical thing, anything that repeats regularly is periodic. Okay, so this gives you an example of a bicycle. Pedaling a bicycle, obviously you can see, when you're pedaling a bike, you're at the peak, and then you kind of reach the bottom point, and then you cycle around, you're back at the peak. This says make a table showing the height of a bicycle. Add all of those. Well, at 0 seconds, the height of the bike is 18, because 18 is up at the top. At 0.5 seconds, you can see this halfway point is 11 inches, so we're 11 inches off the ground. At the bottom point at 1 second, we're at 4 inches. And notice by 2 seconds, we're back where we started. So it looks like it repeats every 2 seconds. So there's that table filled in. You can see we start at 18, The midpoint right here at half a second is 11. The low point at a second is 4, and so on. And then back at 2 seconds, we're back where we started at 18. Okay, it says identify the period. Well, we said the period is how often it repeats. It repeats every 2 seconds. So we have a period basically of 2 seconds. That's really all we can do. And then we want to graph this function. Let the horizontal axis represent the time, and the vertical axis will be the height. So it looks like we're going from 4 to 18. So this is not going to be drawn to scale, but let's say this is 4, this is 11, and this is 18. Obviously not drawn to scale. Here's 0. Let's make that 0.5. Let's make this 1. We'll make this 1.5. We'll make this 2. And we don't really need to go much more than that. So at 0 seconds, we're at our high point of 18. At 0.5, we're at 11. At 1 second, we're at 4. 1.5, we're back up like in the middle part of the bicycle pedal. And most periodic functions are going to look like this. They're going to have kind of this wave-like function. Then 2.5, we're back into another period. So you can see when we connect the dots, this is kind of what the graph of sine and cosine is going to look like. It's like this kind of wave type thing, and you can see it repeats from here to here. That's a peak to a peak. We're going from 0 to 2, and we said the period is 2 seconds. Okay, that's a little bit better picture that you can see right there, and it just shows you the period, so you can kind of gather what's the height of a pedal at different stages. Okay, here's a unit circle, and this is kind of with all the values filled in. So I'm not going to repeat this. I made another video it's in the same playlist. It's called An Easy Way to Memorize a Unit Circle. I just want to point out one thing. As confusing as this looks, if you know, for example, if you know just these 3 angles I mentioned, 30, 45, and 60, then you can fill in all the other ones. And I'll just show you for 30. So here's a 30-degree angle. We know from that chart that we memorized earlier, it was this table, and I said the sines count up, the cosines count down. Let's just stick with 30 for now. 1 over 2, and this is radical 3 over 2. If you know that, you know a whole bunch of other stuff in this table as well. So notice here's the cosine, here's the sine. So this 30-degree angle right here, it also has a reference angle over here of 30, and it has a reference angle over here of 30, and it has a reference angle over here of 30. So if you know that the cosine of 30 is radical 3 over 2, then you know the cosine over here is going to be the same except negative. And how do you know that? Because this acronym says all students take calculus. Cosine is positive here, and it's positive down here. So that means this reference angle of 30 has a cosine of root 3 over 2, just like this one. And in these 2 quadrants where cosine is negative, we're also going to have radical 3 over 2, but it's just going to be negative radical 3 over 2. Okay. What does it mean when we talk about a reference angle? A reference angle means the angle that takes you down to the closest x-axis. So that red part that I just drew there takes us down to this, which is 180. So that means this angle here is going to be 180 minus 30, and that's 150. Okay, let me use a different color here. This angle right here, this purple one, is going to be 180 plus that 30, which is 210. That has the exact same cosine, though, because if you look at this right here, this x distance, sorry, that y distance is the same as that y height right here. They're both 1/2. This x distance, so that purple distance back to 0, is the same as this x distance. The only difference is here you're on the left side of the y-axis. That's why it's negative. Here you're on the right side. That's why it's positive. Okay, notice that this x-coordinate right here, is actually the same as this x-coordinate right here. You're going the same distance away from 0. So that's why this is positive root 3 over 2. That's positive root 3 over 2. So if you know 30, you also know 150, 210, and 330. And vice versa for the other one. So if you know 45, you also know 135, that's 180 minus 45. You know 180 plus 45, that's this one. And you know 360 minus 45, that's this one. Notice again, they're all root 2 over 2. Same thing over here. Everything is root 2 over 2 because we're dealing with 45, and that's what sine and cosine are. The only difference is cosine should be positive here. So it's positive, and it should be positive here. And it should be negative right here and right here because all students take calculus. Sine and tangent are positive there, but not cosine. So that's just a kind of a trick or a shortcut for knowing the unit circle. I would recommend printing off a blank unit circle. You can Google blank unit circle and just try to practice filling it in. It's not so hard to do with a little bit of practice. And then these angles up here, these orange dots that I'm writing right here, these are important because they're at the quadrants. So this is 0 degrees, this is 90, this is, well, they're already writing it, that's 180, and this is 270. Okay, and you could see, I mean, you know that a unit circle has a radius of 1, so you know this is going a distance in the x direction. It has to be going a distance of 1, because that orange radius I just drew was 1. You haven't moved on the y-axis, that's 0. Like I said, I don't repeat that other video, but I recommend watching it. It's called An Easy Way to Memorize a Unit Circle. There's a bunch of them out there on YouTube. You can watch this one or any other, but it's definitely worthwhile to know because you use that in a lot of other math classes besides Algebra 2. All right, so last thing is let's actually calculate some values using these unit circles. So it says find the exact value. Well, first of all, this is outside of 360. So what we want to do is take away a 360 because 480 would be, there's 360 and then you're going somehow beyond that. So let's just take out the 360. 480 is the exact same as 120. So if we draw our unit circle, here's the unit circle. Well, remember this is 90 right here and that's 180. So 120 would be maybe roughly about right here. That's approximately 120. Okay, now the problem is our three important angles that we know are 30, 45, and 60. We don't know directly 120, but we can find it by noticing this. We can notice that from 120 down to 180, that's a 60-degree reference angle. So this is actually the same thing as the cosine of 60, because cosine is the x-coordinate. The x-coordinate right here is really going to be the same as the x-coordinate right here, with one exception, and the one exception is, according to this acronym, all students take calculus. Because you're in the second quadrant, x in the second quadrant is negative. So to find the cosine of 120, we just need to find the cosine of 60, which from that table we memorized is, sorry, it's 1/2, but it's going to be negative 1/2 because we are in the second quadrant. So negative 1/2 is the answer. Okay, 11 pi over 4, it's usually easier to reason or think in terms of degrees instead of radians, so I'm just going to change that to degrees right here, and that turns out to be 495 degrees, I believe. That's right. Okay, because that's more than 360, we'll subtract away the 360, so we'll get 135. This is equal to the sine of 135 degrees. That's not one of these three angles, but it is going to have a reference angle of one of those, and it's turned out to be 45. There's 135. The question is, what angle takes us down to 180? And the answer is 180 minus 135 is 45. So sine of 135 is actually the same as the sine of 45, and it even has the same positive or negative because 135 is in the second quadrant and sine is positive in the second quadrant. This y-coordinate right here, whatever that is the exact same as this y-coordinate right here, which is the sine of 45. And you may remember from the table the sine of 45 is radical 2 over 2. The problem is, if you put this in a calculator, it wouldn't give you the exact value. It says find the exact value. So I'm going to put in sine 45 right now, just to show you. The exact value is something that it's like pi or something that's an exact square root. It's not a rounded answer. So when we do that, we get 0.707. And just to verify, 135 should be the same. Okay, but both of those answers would be wrong. If they're asking for an exact value, the radical 2 over 2 is exact. Okay, and you can prove that this is the same. So if we actually calculate what radical 2 over 2 is, you can see it's 0.707. Okay, but we need to keep it as radical 2 over 2 because they're asking for an exact value. Alright, so that is pretty much the end of the section. Maybe we'll just do one more here just so I can show you. And when I just want to show you how to do it in radians. We did change it to degrees. So if you were to change negative 3 pi over 4 into degrees, you would get negative 135. Okay, but I want to show you how you do this without having to change it. So because it's negative, let's go the other way. So this normally would be 90, 180, and 270. But if we're going negative, negative means go this way. So this would actually be negative 90. This would be negative 180. And positive 90, that's equivalent to negative 270. Okay, how do you change things easily from radians to degrees? I would just remember this. And if you remember this conversion, it's easy to find the other ones. Okay, these are the good ones to memorize if you are going to memorize any. And I'll show you kind of an easy way to do this. We'll add 30, 45, and 60 real quick also. And again, it's not, you could easily calculate these if you don't have them memorized, but it's still a good idea just because they're used so frequently. So if 180 is pi, that means 360 is double 180. So that means it must be double pi, which is 2 pi. 90 is half of 180, so that must mean it's half of pi, or pi over 2. Okay, so this right here is like 1/2 pi. This is like 2/2 pi, which is just pi. 270 is like 3/2 pi, and this is like 4/2 pi, 4 pi over 2, and that just equals 2 pi. Okay, now let's look at 180. What do you do to 180 to get to 30? You divide it by 6, so that means in radians that would be pi over 6. What do you do to 180 to get 60? You divide it by 3, so that's like pi over 3. And how do you get 180 to 45? You divide it by 4. So that's pi over 4. So those are good ones to have in mind. So negative 3 pi over 4 is negative 135. Well, let's just do this way. We know that this is negative 90. We know 90 is pi over 2, so that's like negative pi over 2. Since we're dealing with denominators of 4, let's change pi over 2 into negative 2 pi over 4. And similarly, let's change negative pi into negative 4 pi over 4. So if it's negative 3 pi over 4, if that's our angle, that would be between negative 2 pi over 4 and negative 4 pi over 4, almost exactly between them. Okay, so that angle is negative 3 pi over 4, or if you prefer, negative 135 degrees. How do you find the positive version of that angle if you're dealing with negatives? Well, basically the positive version would be like if we had gone this way. And that's just, you just do 360 minus the negative angle, and that turns out to be 225 degrees. The reference angle is this, the angle that takes you back to 180. We could just do 225 minus 180, and that gives us 45. So the cosine right here is the same thing as the cosine of 45. The only catch is we are in the third quadrant where cosine is negative, because only tangent is positive. So the negative cos of 45, and that will be negative radical 2 over 2. And let's just verify, and there it is right there. So that is 12.6 on the unit circle. It's a pretty important idea in trigonometry. Hopefully it makes some sense to you.